Hi folks, I am Omkar and I am from mechanical engineering student from India, and I am started my new channel to teach you physics, and my basic aim is to make you love physics and to draw your interest and to draw your attention towards physics, because I am a physics guy. I love physics more and my most favorite subject is physics. So I have decided to teach you physics in a very simplified way and a very easy way. So before I will start my subject, I want to tell you that I have following the book is The Concept of Physics, written by Professor Harish Chandra Verma from IIT Kanpur, and it's a very good book. I have started from that book, and that is a very motivational book also. I know it will not be wrong if I will say it motivational, but it's a very good book. You can follow that book to read and to see more important problem solving and other stuff, whatever you can say, but that is my recommended book here. So I have first decided to go to the topic of the unit and dimension. It is a very fundamental topic and the beginner's topic, unit and dimension comes the first topic in the entry level from the 11th standard when the secondary education is started. So I have decided to start from there. So let's directly go to the subject, unit and dimension. Unit and dimension is a very fundamental topic. It is a very important one. If you are very strong in this topic of unit and dimension, it will be very helpful to handling the equations, handling the systems, handling the measurements, and converting the units from one system to another. There are many systems of unit. You can say SI units, and in case whatever the system, CGS, pound formation, whatever, pound, square, inch, and whatever the system, you can easily convert from one to another. You can check your equations, if it is right or wrong. Partially you can check it. If it is not unit is correct, then it is totally invalid, just gone. You cannot say you can say like 1 kilogram is equal to 2 seconds. Is it valid? No. You have to say kilogram should be equal to kilogram. If you are writing in equations, 1 kilogram plus 2 seconds is equal to 3 mole. This is nudgy. You cannot say that. So from this concept you can validate whether equation, your new research equation, you are researching guy and you are finding new equations, whether it is correct or not. That is a very crucial point, and it has many applications in your higher studies, also in the advanced physics also. And this is a very fundamental thing. You can learn it. If you are strong in it, it will be very helpful. Let's directly go to this topic of the unit and dimension. Okay, so why the unit and dimensions are coming? Why it is required? From the very basic, let's take suppose there are the research person who has been initiated to categorize the thing, and they decided to measuring the thing. Means I'm walking to my room to my college. How much distance I am walking? This is a very simple questions. How can you answer it? No, if you were not using unit dimension, you have no questions. You have the questions, but you have no answers. How can you answer that? I'm walking daily from my room to my college, attending class and coming to my room. Now someone asks, how much distance you walk? I don't know. So to answer that, I need a unit and a dimension system. To specify the thing or to measuring thing, I need a very common basis. Like if you have a little bit knowledge in the vector, you can say if you have two axes and I don't know, maybe I have no axis, I have a vector. Initially, how can I define this vector? I need a two basis vector. I can say if I have a basis vector of in I direction, I have a basis vector in the z direction, I can say, well, it is 1.5 times in the I direction and 2.5 times in the z direction. This is the definition of the vector. Like that, to define your distance, you can say, I need a unit, I need a scaling, I need a scale, I need a basis to which I can measure that. That is the very basic concept of the unit. That's why to measure something, to evaluate something, and to express your ideas, the amount, you need a units. So that is the very basic requirement of the unit. Now research persons, I don't know exactly who is that research person, but my respect to him is great, and they have been categorized the total entity, entire entity unit to measurement with some very basic basis. Like, you know, if you are I'm again coming to the vector concept, and if you have a vector in your 3 dimension, then you need a 3 basis vector to define a single vector in the I direction, j direction, and along the g direction, or you can say k direction, okay, whatever it may be. So you can say some component in the I direction, some component in the j direction, some component in the k direction. You need a basis vector to represent a total vector. Exactly the thing, to represent the entire total system, whatever that it may be in your atmosphere or in your surrounding, you need 7 basis component that has been derived, 3317, 7 basis component that has been taken as the basis component, if it is not wrong to use the word basis, as that is the word of the linear algebra. So these are the basis component that scientists have been taken, a researcher or the developers have been taken to measure the entire stuff. What are these? One is the length, measuring the distance, how much distance I have covered, exactly I was giving the example a little bit later. Then mass, means I can lift this much amount. What is the mass? Maybe 20 kilogram. That comes the word kilogram. That is the mass. Time, I can solve the problem. Means how much time it will take. That is the time. Is not I don't know, maybe 20 seconds. That is the electric current. It's a little bit sneaky. Electric current stands for how much current is passing through a conductor. Means it will be similar to represent that the flow of electron. How much electron is flowing. This is the electric current is a single entity. This is the electric current. That is the temperature. My body temperature is, I don't know how it is. Water feels warmer. I am cooler. Ice is cooler. Water is warmer. Steam is more or warmer. So how can I represent the temperature? Means I need a temperature. That is the temperature. Amount of substance. Oh, well, I am handling this pen. How much amount of substance I am handling? Can you define that? That is the amount of substance. It is denoted as mole. Electric current is ampere. 1 ampere, 2 ampere, 50 ampere, 13 ampere. Temperature 20 degree, 30 degree. Well, this may be Kelvin. This is the SI unit. I have written here SI unit. I will talk about what type of unit is here. This is the SI unit. That is the Kelvin. Another one is luminous intensity. Well, I can say I am here. Some stuff of light is coming from here, here, here. How much light is coming? How much light is falling on me? That is called the luminous intensity. I don't know. Means light is coming from that ball. Light is coming from this ball. Light is coming from the board. Light is coming from my camera. How much light is coming? To measure that, I need a term that is called luminous intensity. The amount of the light falling on me is called the luminous intensity. Now let's talk about this unit. Length, its unit is meter. This is a meter. Then mass, this is known as kilogram. In short, you can write it has a symbol, meter. You can write it m. You can kilogram. You can write it's kg. Second, 1 second. That is called as is. Ampere, it has a symbol denoted as A. Kelvin, it is the temperature. Kelvin is denoted as K. Amount of substance, how much substance it is, sorry. Amount of substance, that is called as the mole. 1 mole, 2 mole. Do you know what is mole is? If you have learned in chemistry, so perhaps that is 1 mole is equal to, there is a number, I am forgetting, that is the 6.023 into 10 raised to 23 number of atom, that is called Avogadro number. Yes, that's called Avogadro number. A naught, basis is A naught, this is the A naught, that is called Avogadro number. 1 Avogadro number is equal to 1 mole. Means if you are taking oxygen in a cylinder, I don't know how much oxygen, how to specify the amount of oxygen. If you are taking the atomic mass of the oxygen, let it, I think it is 8, I'm forgetting the number, it is 8. If you are taking 1 mole of oxygen, it will give you 8 gram. 8 gram, if it means, in other words, if you take 8 gram of the oxygen here, it will give you 1 mole of the 1 mole of that substance, that is called as the mole. Another term is called candela. Candela is a unit to measure the luminous intensity, how much illuminated it is, how much extent it is glazing. I can increase my luminance, I can decrease my luminance, I can switch up that bulb, luminance is decreased. So this is called CD, not cadmium. This is CD. CD stands for candela. These are the basic units or the tools to measure something. That is called the basic unit of the meter. Now I am asking questions. Suppose I am telling that I can do my calculation within 20 seconds. This is a very beautiful concept. Let's start from here. I can do my calculation within 20 seconds. Well, another guy will say, no, I can do it within 10 seconds. So another guy will say, no, I'm much more ridiculously sharp brain I have, I can do it within 5 seconds. So who specified this term second? Means how much time, who would tell that this time will set as the second? No, it is not arbitrary, it is fixed. Like I can give you example, this is a very interesting thing. 1 meter, let's talk about 1 meter. I have noted down from my book. 1 meter is equal to the distance traveled by the light within 1/299,79245 second. That is equal to 1 meter is equal to, as per you can say, the speed of the light is constant. So for this constantness of the speed of the light, they have fixed the meter unit, means the light will travel at the same speed in every frame of reference. So there is no, no relativity now. It is a very beautiful story, I will tell you later. Relativity, wow. 1/299, it seems like a mobile number or contact number of someone, 79245 second. So this is a fraction of time that in that time how much distance light will travel is known as 1 meter. Similarly, another I have interesting story, to measure 1 second. How can you measure 1 second? 1 second is the cesium atom oscillates and radiate electromagnetic wave between its two transition or the two neutral state, means this is the first radius and this is the second radius. Electron oscillates in between, and 1 second is equals to 631,770 oscillation is called 1 second. Means electron will oscillate in between, and 1 second is equal to 1 second will that much of time when this electron will oscillate this number of oscillation. When this electron will complete this number of oscillation, then the time required to complete the electron to this number of oscillation, that is 9,172,000,000. Oh wow, 631,770. Who fixed that? I don't know. Oh God. The electron oscillates in between two two orbital, and to complete oscillation, this number of oscillation, the time required is the 1 second. This is the definition of 1 second here. God knows who derived that, and I don't know that. I'm not sure about it. And this is the this is the thing, or this is the scaling of this fundamental concept or fundamental units here. Now let's go to the use of this dimensional analysis. Yes, we have learned a lot of things here. Now somebody will ask you, what does this use? Why we will learn that? Means why? It has many use applications. I have told you before, to apply the or to check your correctness of your research equations, and to convert from one unit to another unit, and and another one is the unit conversion. Yeah, this is the same thing. Maybe perhaps I have a concept. I can write the force to check whether the force is equal to joule into meter or not. Means I can say, suppose I have a unit, I mean this is wrong, the force cannot be joule times meter, but I can say there is a term called torque. Let me erase my board, sorry. Suppose there is a term called torque. There is a term called torque in mechanics term, and this is defined as your force times the distance. This will give you Newton into and meter. Suppose this is your output result. This gives the unit into Newton meter. So in short, you can write Nm. Another one is there is a concept called energy. Energy is nothing but gives you force times the distance. That is called Newton into meter. That is called as your joule. So to verify that energy, the unit of the joule is equal to the unit of the torque, and to establish the relationship between them is your requirement of the unit and dimension. You can say unit, that is the force of the unit of Newton, and distance having the unit of meter. You can equate them and you can find the relation that, oh wow, torque is nothing but some type of energy. Actually we will learn it in mechanics, how torque is related to energy. So this is a very important thing of the unit and dimension. And one more concept I will tell you, and I will finish it for today. Before finishing, I need to say about some type of units and dimension conversion. Suppose, I don't know, maybe I have 1 meter distance. 1 meter distance gives to how much inch? Inch is another type of measuring the scaling the distance, and I need to convert how much inch is equal to 1 meter. How can I do that? I need to specify how much inch, how much the length of the 1 inch is. Means I need to convert from this unit to that unit. So I know that the 2.5 inch, sorry, I need 1 inch. My mistake is 1 inch is equal to 2.5, approximately equal to 2.5 centimeter. So how can I write that? How can I convert from centimeter to meter? Just multiplying it 100. This is equal to 100 centimeter is equal to 1 meter. So divided by 2, you will get 4. That is equal to 40 inch is equal to, means just dividing 100 over 2.5, that gives me 40. 40 inch is equal to 1 meter. So how much 40 inch is equal to? I can write that is called 12 means 3 feet 4 inch, approximately 2 and 3 and 5 feet. So 1 inch is equal to this much centimeter, and I convert from centimeter to meter, meter to centimeter, then that gives me 100 over 2.5, that gives me 40. So I can write 40 inch, approximately 40 inch is equal to 1 meter. This is a unit of meter, comes a basic type of unit of basic type of use of unit conversion in your unit and dimensional formula. You can use it. This is a very important tools. And that's it for today. No more analysis on the unit and dimension. Next I will go to the vector addition, vector algebra, then we'll directly go to the physics. This is actually the prerequisite of the physics. You need to know about the prerequisite. And if any doubt remains, comment me below, and if you not understand, watch this video again, and if doubt is still not clear, then ask me. I will make another video, or I will teach you again. And I repeat, this is the very important tool. It seems to be very easy, but this is the important tool, and this is a very important concept in your advanced physics also. You can say quantum mechanics, your particle physics, whatever department you may go in physics. This is very helpful, and this is whatever, maybe not in physics, maybe in any engineering. So I am learning mechanical engineering, and I am this is a very important tool to convert the units here. So thank you for today. Please subscribe my channel. If you like my video, please share, and thank you so much for watching.